Hello everyone, hope you have a lovely day. So we have something to fix. Let me show you. We have this package. This is coming from a rural technician. So we received this job in the afternoon. He said he wants to collect it early in the morning tomorrow, that is Saturday. So let's see what we have here. Let's see. We have a LED 32-inch TV board. This is some kind of TV motherboard which came in for repair. Okay. So what the owner said about this board, he said the TV just stopped working. No power, no anything. He tried to check everything, seems to be fine, but still the TV is not powering on. Okay. This is a job from a rural technician. You know, people that are trying to fix things. Obviously, when you are fixing things, you check what you know can be faulty. And yeah, you can't check what you don't know. You can't check what you don't know. So I'll plug the AC cable. AC cable is plugged. Here, we must have like red light for standby here. And the red light is not present. That is the problem with this TV. No standby light, no anything. The TV board is just dead. Okay. Let's start checking some things. Yeah, that's the board. The board looks nice. Okay. Yeah, it looks nice. The board looks nice. So, you know, there's some kind of all-in-one motherboards on these cheap TVs of nowadays. We have the AC in here. The brown thing, that the fuse. Some coil. Capacitors. The big capacitor. Electrolyte capacitor, the 400 something volts. Okay. Next to the coil here, we have a rectifier bridge. So I will check AC on the input of the rectifier here. And 223, you can see on the screen. So at this point, we know that the cable, this AC cable, is bringing 200 something volts into the motherboard. So after the rectifier, (311 volts). That means on the big capacitor with 12 voltage. Okay. So our problem is not from the high voltage area. What you can check on the secondary, we do have the EEPROM IC here on pin number 3, which is the VCC pin 3.31. On this coil 0.92. On this one 5 volts. So even the 5 volts regulator is working. So if everything is working, but the TV board doesn't have standby light, what do you think might be the problem? So either the controller, the processor is dead, yeah, the processor can be dead. You know, that is the weird fault. When everything is okay, but you still don't have standby light. I never seen something like that. Or some time ago, I think I want to have a similar problem like this, but the problem was the EEPROM itself. So what I did, I reprogrammed the EEPROM, and the body came back to life. Luckily, I was having the bin file for that EEPROM IC chip. In this case, I don't really know what kind of 32-inch is this. And you know, I don't have a similar board to this, like this, to swap the EEPROM IC. So where can you start? Let's check something on this coil. 5 volts. We have a chip here. And this chip, I believe, must 9 volts, 6 volts, 5 volts. Why here we have 6 volts? Why here we have 6 volts? Was on this connector, in most of the TV boards were having 12 volts. But why here we have 6 volts? .86. This is not normal. At some point, the voltage gets lost there, because we must have 12 volts there, but we only have 6.86 volts. This is the 12 volts power supply, which is always on. And we have 6.86 volts, which is some kind of strange. Okay. What do you have here? I'm trying to understand a few things here. Let's disconnect the power. Diode mode. You know, when everything is working, but when everything is okay but it's not working, usually we have to focus on 2 things. So what you can do, we can try reheating this processor. I can't see any water damage or anything. Do you think this is going to give us answer? Okay. So how this switching power supply is working? We have the hot side and the cold side. This is the primary stage and the secondary stage. AC in is coming here. Fuse, coil. We have the bridge rectifier, and the plus of the bridge rectifier is coming to this peak capacitor, and is going straight to the primary, to one of the pins of this chopper. You see this big transformer, which is being switched by this MOSFET. And here that the driver, this six leg chip. Maybe you can't see it here. We do have a small 6-leg chip here. This one. So in order to separate the high voltage and the low voltage, they use an optocoupler, which is being managed by the shunt regulator. So either this shunt regulator can be faulty, or the processor can be faulty. But we read the processor. So let's check again. Yeah, the board is plugged, but we still have no light. That means the problem is not yet solved. Yeah, the problem is not yet solved. Let's go under microscope and try to locate the TL431 shunt regulator. So what do we have here? We do have the AC in. That is the MOSFET, which I believe is that is the N-channel MOSFET. I want to concentrate on this area here. You can see this optocoupler, which is managing the high voltage and the low voltage area. Let's see now. Diode mode. We have this optocoupler. Where this track is going. It's going straight here. You can see the beeping of the multimeter. And this one. So you can see 0, 0. So I'm 100% sure that is our optocoupler. That is our TL. I can't see the writing of the chip, but this must be TL431 shunt regulator. So let's replace that chip. The chip is out. Looking for another one. Let's try to look for another one. We have another one here. You can see that one, that small one. That is shunt regulator. So I'll take this one out. This is just a board for spare. Okay. That's our chip. You can see that is our shunt regulator, a BR431. So let's wait for the board to cool down and then we can test together. Let's see now. Let's just inspect other parts of the board to see if there's anything that we can visibly see. That the processor, and here we have this, that the EEPROM, BIOS, memory, whatever I call it, this one. Everything looks fine. Let me test for those capacitors for not being short. No, we don't have a short. So let's see what's going on here. Let's see. I'll plug the AC cable. AC cable plugged. What is here? Huh? I told you. Check the light. It's working. Huh? Ah. If I see a standby light back, I know that the probability of having a working board is very high. Let's try to power on this board. Power on. Change to green. Off. Now red. Now green. Now red. It's changing. Now the board is on. You can see the green light. So we are done fixing this motherboard. What I want to check that place, that 12 volts, which is always on this connector, ground, How can I do it? 1 second. Volts. Let's check. Let's check what voltage do we have here. 12.25. You see? Now we have a working motherboard. Trust me. Because we checked here, there was 6.86. On the shunt regulator, 9.7, 2.43. Okay. The 5 volts is present. Voltage for the backlights, 23 volts. 3.3 present. 1.92 probably for the processor. So we now have all the voltages. And the board is still on. You can see here, still green. I'll turn it off. You see that green is changing to red. Now it's red. Now it's green. Now it's red. Now it's green. So this job is done. I'll repack the motherboard and I'll call the owner to collect it. And he will go and assembly and give me the feedback. So that was the job that we have on a Friday. What can I say? Like, subscribe. Don't forget to turn on the notification bell for future updates. Also share our videos to your friends, relatives, and friends all over the world. And see you on the next job. Bye.